So now let us continue with our lesson on categorical variables, analyzing categorical variables. Actually, this is somewhat related to the chi-square. Okay, so usually collect information on exposure and disease because we want to compare two or more groups of people. And to do this, we calculate measures of association. So measures of association tells us that the strength of the association between two variables such as exposure and the disease. So two measures of association that we use most often are the RR, or that is a relative risk, or others call it the risk ratio, and the odds ratio OR. So the decision to calculate an RR or an OR depends on the study design, and we interpret RR and OR as follows. So if RR or the OR is equal to 1, so that means exposure has no association with the disease. If it is greater than 1, that means exposure may be positively associated with the disease, and if it is less than 1, exposure may be negatively associated with the disease. So the risk ratio or relative risk is used when we look at a population and compare the outcomes of those who were exposed to something to the outcomes of those who were not exposed. So when we conduct a cohort study, we calculate risk ratios. However, when our design is case control, it does not allow us to calculate risk ratios because the entire population at risk is not included in the study. That's why we use odds ratio for case control studies. And odds ratio is the odds of exposure among cases divided by the odds of exposure among controls, and it provides a rough estimate of the risk ratio. So remember, for a cohort study, we calculate risk ratio RR, and for case control, we calculate OR. So this is maybe the best time to discuss on our 2 by 2 table, our favorite analysis table, 2 by 2. So you should be familiar with the 2 by 2 table, and these are commonly used with dichotomous variables to compare groups of people. And the table has one dichotomous variable along the rows and another dichotomous variable along the columns. So this setup is useful because we usually are interested in determining the association between dichotomous exposure and dichotomous outcome. So for example, the exposure might be eating salsa at a restaurant or not eating salsa. And the outcome would be getting a hepatitis A or being infected with hepatitis A or not. So if we have this table, it displays the case control study conducted in Pennsylvania in 2003. So what measures of association can we get from this 2 by 2 table? Since we do not know the total population at risk, so we cannot determine the risk of illness among the exposed and unexposed groups. So we are only contented with the data that is provided those who are dining in on that restaurant A. So if you notice, 263 ate salsa and 218 had hepatitis A, while 45 did not have. Of those who did not eat salsa, okay, 106 of them, and 21 still has contacted with hepatitis A, while 85 do not have hepatitis A. So your entries for A is 218, for B is 45, for C is 21, and for D that is 85. So if you are going to compute the odds ratio using the formula AD over BC, so you will get 19.6. That is by hand. But if you are going to use use an online calculator, odds ratio calculator, you can also do that and you will get the same answers. If you notice, you just simply plug in there the values without really memorizing the formula, and voila, you have your odds ratio and you already have your 95% confidence interval. And when we say confidence interval, we already have discussed that in our estimation of parameters. There are two things that we need to remember when we construct confidence interval. We need to have our point estimates, and that is the calculated estimate like the risk or the odds, or the measure of association like the risk ratio and the odds ratio. So when we say confidence interval of a point estimate, that describes the precision of that estimate, and usually we have uh, 95% the most common confidence interval. And we have to remember that the narrower the confidence interval is, the more precise is the point estimate. Okay, so to understand better, let us have this example of a large bag containing 500 marbles, which consist of red, green, and blue. But we do not know how many are each of the red, green, and the blue in that 500. So we would like, for example, we are interested in the green ones. So we would like to know how many are the green marbles. But you don't have to count every one of them because it is, lengthy, 500. So it's not going to be practical. But what is practical is you are going to select a sample and have an estimate of that sample. So how will you do that? You can shake up the bag and you're going to randomly select 50 marbles. And of the 50 marbles, you count how many greens, reds, and blues. So in that example, there were 15 greens, 10 red, and 25 blues. And based on the sample, we can conclude that 30% or the 15 out of 50 marbles in the bag are green. So in this example, 30 is our point estimate. Are we really confident in stating that 30% of the marbles are green? Okay, so I think we are not that confident. We are having some doubts about that statement. So if because we do not know that 30% is really correct, so there is a chance that it's not really 30%. It could be higher or it could be lower. So to do that, to erase our uncertainty, we're going to calculate confidence interval. Conducting confidence interval, calculating confidence interval can be done using EpiInfo, SAS, Theta, SPSS, and the EpiSheet. Common statistical programs, but you can always go to the internet, search for the uh, calculator for the confidence interval, and you just have to input your values and you have to choose whether it's 95, 90, or 99. But the most common is the 95. So if we are going to go back to our example of green marbles, we assume, or if we do manual calculation, we knew that the 95% confidence interval would be 17 to 43%. So I'll show you the manual computation, but I think we already have that in our previous lesson. Or if you're using an online calculator, you just have to search confidence interval for a proportion calculator and you are presented by different options, and it's up to you to choose which one you work with. It makes you comfortable. So in this case, I'm using that. So I just plug in the sample size, which is 50, and 15 out of the 50, those are the greens. So that is the one that we are looking for. And the confidence interval is 95. So when you click calculate, you are given two options. That is the binomial exact calculation and the normal approximation of the binomial calculation. So the second one is approximating more or less our manual computation. So the manual calculation is done by that the point estimate plus minus the margin of error. And that margin of error is the z value times the standard error of the proportion, which is PQ over N, and you get the square root of it. So doing it manually, that's how it is done. And if we want to have 99% confidence interval, we're allowing only 1% error. So we can always change that, or if you want more error to occur, like 10%, so we can compute the 90% confidence interval for the green marbles. And you have that manual calculations for the 99% CI. So if you notice, it becomes wider. So the width of the interval is wide compared to the 95%, which is 13 to 43. But in that case, you are going to, 17 to 43. And then if you are going to have the 99%, that is 13 to 47. When you do also the 90%, still it is wide from 11 to 41%. Ideally, we would like to have a very narrow confidence interval, which would indicate that having a narrow confidence interval, our estimate is very precise. So how to do that is increase the sample size. So by increasing the sample size, you are narrowing the confidence interval. So if you increase the sample size to 100, getting the same proportion of green marbles, which is 30%, notice that the interval is going to be 21 to 39, unlike in the 50 sample size, which is 17 to 43. So take a look at the range of values. When it is 17 to 43, you have 26 as the range, and if you have 21 to 39, you only have 18, so it becomes narrow. And if you're going to increase your sample size to 200, getting the same proportion of greens, 30. And so your 95% confidence interval is 24.60, 24 to 36. So that means it is now becoming narrower. So 24 to 36, you only have 12. So notice that as you increase your sample size, confidence interval also becomes narrower. And if we return to our hepatitis A problem, if you remember the confidence interval, it is 11 to 35 approximately. Okay, so that means that you still have 11% chance of getting Hepa A if you eat salsa. Okay, so confidence intervals must include CIs with your point estimate. So that is to give sense of a precision of the estimate. So it is very necessary to include intervals with the point estimate. And that way, you can give a sense of the precision of your estimate. So here we have this example of an outbreak of gastrointestinal illness among in two primary schools in Italy, and investigators reported that children who ate corn salad or salad of corn and tuna had 6.19 times the risk of becoming ill than those of children who did not eat salad. And the confidence interval is 4.81 to 7.98. On the other hand, if we're looking at the pertussis outbreak, or that is the whooping cough outbreak in Oregon, case patients were 6.4 times the odds of living with a 6 to 10-year-old child that controls. Okay, so that means to say that mm, they are living with a child with pertussis. So, what can you conclude? You can say that through association between, there is association between exposure and disease on the two examples. Okay, so again, when we are going to analyze categorical data, we can either measure association, that is by risk ratio or odds ratio. Then we are going to have the confidence interval, and we are going to use the chi-square test, that is the formal statistical test to determine whether results are significantly, statistically significant.